Welcome to the Solidworks tips and tricks session. Today, we're looking at one of the fastest ways to assemble your models, smart mates. Smart mates allow you to create mates on the fly without having to go back and forth to the mate command. Here, we have an assembly of a motor knee. However, we still require the VF2 foot model added to this assembly. I will start with the base part to create a new assembly from this part. Then click OK to confirm the fixed part. Next, I'll add the sole component to the assembly from the design library location. Then, by holding the right mouse button down, I will rotate this component to expose a suitable edge to mate with. By simply dragging and dropping component faces, edges, or vertices while holding the Alt key, Solidworks will automatically predict and apply the correct mate. Here, the outside edge of the inner sole is mated to the outside edge of the bottom base rim hole, forming a peg-in-hole type mate. Next, I will add a width mate by holding the Control key, selecting the cylindrical face of the base and two planar faces of the inner sole cavity, then releasing the Control key to activate the Quick Mates context toolbar. Inserting two spaces here will allow us to use two flanged button head cap screws, which can quickly be mated using Smart Mates while holding the Alt key and dragging the model edge for the appropriate mate reference. Here, we can see just how quickly these types of Smart Mates create concentric and coincident type mates. A main linkage assembly will be added, and these can be utilized with Smart Mates similarly. By holding the Control key and using smart ways to select faces, I can use tools like Select Other to select and confirm my mate selection, then release the Control key to choose the width mate from the Quick Mates context toolbar. Furthermore, using a cylindrical face to Smart Mate this to the base. Next, I'll bring in the shock mount components and Smart Mate them too. If components need to flip alignment, the tab button on the keyboard can be used before releasing the mouse button, allowing components to be fitted in their correct position upon being mated. Lastly, mating the final shock mount the very same way. Now I'll add a short linkage and mate the cylindrical inner face to the corresponding interface of the main linkage assembly, making use of the Smart Mates. Then, once more using the Select Other option, I can quickly hide and easily multi-select the faces to create a width mate. I would now like our next component to be added, which will be our shock. So I will start by creating an assembly with the base component of the shock. Then, by dragging and dropping, I will insert the lower shock part, using the outer cylindrical face to create a concentric mate with the outer cylindrical face of the upper shock. Using the Control key to access the Quick Mates context toolbar while selecting the appropriate faces, I can specify a limit distance mate for this lower shock, starting at 0 millimeters for a maximum travel distance of 70 millimeters and a minimum of 7 millimeters, making sure that the desired outcome is achieved for this shock. I will then proceed to insert the additional components and use Smart Mates on the top and bottom of the shock assembly. By adding the shock to the main assembly, I'll create another peg-in-hole Smart Mate, ensuring proper alignment during mating with the Tab key. I will make this sub-assembly flexible, then use the circular faces of the upper shock mount and the short linkage to establish a smart-mated concentric mate. I'm going to add the rest of the components, starting with the clamp at the top and creating another peg-in-hole mate here, followed by a concentric mate for the opposite hole. Next, I'll add another linkage component here and hold the right mouse button to drag and rotate the component. Then, mate the top circular edge to the upper linkage and the bottom to the base frame. Examining the side view, we can see the movement achieved by the assembly, which accurately aligns with the shock's movement constraints. Lastly, I'll add the foot guard component to the assembly and rotate it into position. Then zooming in here to accurately select the inner circular edge to smart mate this with the outside edge of the connecting base part. Now using the lower planar face of the foot guard, I will mate this parallel with the top plane of the assembly using the Quick Mates function. With all the toolbox components added, I can now insert the VF2 foot model. The upper rod of the clamp is mated here using Smart Mates. Then focusing on the outside edge of the clamp, this can simply be mated to another face to form a coincident mate using Smart Mates. Looking at the side and isometric views, this Moto knee and VF2 foot model is now complete.